universe is a place of incomprehensible beauty and mystery. It is vast beyond measure, stretching farther than the mind can fathom, and teeming with wonders we are only beginning to understand. For millennia, humans have looked up at the night sky, captivated by the twinkling lights and asking the same questions. How did all this come to be? What lies beyond what we can see? What does it mean for us to exist in such an immense and intricate cosmos? To contemplate the universe is to confront the infinite. The stars scattered across the night sky are not just distant suns, but portals into the vast expanse of space and time. Each point of light represents a story that began billions of years ago, its journey spanning unimaginable distances to reach our eyes. The immensity of the cosmos humbles us, yet it also fills us with awe and wonder. It invites us to dream, imagine, and embark on a journey of discovery. The immensity of the universe. The universe is vast beyond comprehension. Even the most miniature scale of cosmic distance is staggering compared to our everyday experience. Take the Earth, for example, our home, with its towering mountains, deep oceans, and sprawling landscapes. It feels immense to us, but on the scale of the universe, Earth is barely a grain of sand in an endless desert. The solar system, our immediate cosmic neighborhood, spans an incredible distance. From the Sun to Neptune, the outermost planet, the distance is about 4.5 billion kilometers, 2.8 billion miles. This distance is so great that sunlight traveling 300,000 kilometers per second, 186,000 light years, leads about 4 hours to reach Neptune. Yet, even the solar system is a speck within the Milky Way galaxy. This vast, spiral-shaped collection of stars, gas, and dark matter spans 1,000,000 light years. It contains 200 billion to 400 billion stars, each potentially surrounded by planets, moons, and other celestial bodies. But the Milky Way is not unique. It is one galaxy among trillions in the observable universe. Each galaxy contains billions or trillions of stars, and between them lie immense voids of almost space. The observable universe spans 93 billion light-years in diameter, a distance so vast that even light, the fastest thing in the universe, would take billions of years to traverse it. And beyond this observable boundary, that remains one of the greatest mysteries of all. The universe could be infinite, stretching endlessly in all directions. Or it might be finite but unbounded, curving back on itself like the surface of a sphere. Whatever the case, the accurate scale of the cosmos is far beyond our comprehension. Time and light, the universe's storytellers. The vastness of the universe is not just a matter of distance, it is also a matter of time. Light, the fastest traveler in the cosmos, moves at an incredible 300,000 kilometers per second, 186,000 miles per second. Yet even at this speed, it takes time to cross the immense distances of space. When we look up at the night sky, we see stars not as now, but as they were in the past. The light from the nearest star system, Alpha Centauri, takes 4.37 years to reach us. The light from the Andromeda Galaxy, our nearest galactic neighbor, has traveled for 2.5 million years before arriving here. The light from the most distant galaxies in the observable universe has taken over 13 billion years to reach our telescopes. This means that when we gaze into the depths of space, we also look back in time. The universe reveals its history through light, carrying stories from epochs long past. Every star, every galaxy, every glimmer of light in the night sky is a message from the past, a window into a different era of the cosmos. The cosmic web, a tapestry of light and shadow. The structure of the universe is as beautiful as it is vast. Galaxies are not scattered randomly through space. They are arranged in a cosmic web, an extensive network of filaments made of galaxies, dark matter, and gas. These filaments stretch across the universe, connecting galaxy clusters and superclusters like the threads of an intricate tapestry. At the intersections of these filaments lie the densest regions of the cosmos, where gravity has pulled galaxies together into immense clusters. In contrast, vast voids lie between the filaments, regions of space where matter is sparse and galaxies are few. This cosmic web was shaped in the earliest moments of the universe, during a period known as cosmic inflation. Tiny quantum fluctuations in the fabric of space-time were stretched to enormous scales, creating the seeds of the structures we see today. Over billions of years, gravity amplified these fluctuations. The scale of the cosmic web is almost impossible to grasp. The largest structures, known as superclusters, span hundreds of millions of light years. Yet these structures are just one small part of the observable universe. A humbling perspective. Given the vastness of the universe, our place in it seems impossibly small. Earth, our home, is a tiny world orbiting an ordinary star on the outskirts of an unremarkable galaxy. Yet it is the only place we know of where life exists. The atoms in our bodies were forged in the cores of ancient stars and scattered into space when they died. Over billions of years, those atoms came together to form new stars, planets, and eventually us. We are made of star stuff, children of the cosmos, connected to the universe in profound and intimate ways. This connection between ourselves and the cosmos is both humbling and inspiring. It reminds us that while we are small, we are also part of something vast and extraordinary. An invitation to wonder. Tonight, we invite you to join us on a journey through the most incredible facts about space. Facts that challenge our understanding, expand our imagination, and inspire us to wonder. Together, we'll explore the vastness of the universe, the lives of stars, the mysteries of black holes, and the hidden forces that shape the cosmos. But this journey is not just about learning, but reflection and relaxation. As you listen, allow yourself to be carried by the soothing rhythm of the narration. Let the awe of the universe calm your mind and ease you into a state of tranquility. The cosmos is calling, its wonders await. Let us begin. The scale of the universe. The universe is a symphony of unimaginable scale. Even the most minor corner of space can stretch beyond human comprehension, leaving us awestruck by its vastness. To grasp its sheer size, we must journey from the familiar to the infinite, where each step reveals another layer of immensity. Earth and its cosmic neighborhood. Let us begin with Earth, our home. At 1,274, 2 kilometers, 7,918 miles in diameter, Earth feels immense to those who walk its surface. Its vast oceans stretch beyond the horizon, and its tallest mountains rise into the sky. But compared to the vastness of space, Earth is barely a speck of dust. Orbiting Earth at an average distance of 3,84400 kilometers, 2,38855 miles, the Moon is our closest celestial companion. If you could drive to the Moon at highway speeds, the journey would take over 5 months of continuous travel. Yet in cosmic terms, the Moon is practically touching us. A mere heartbeat away in the scale of the solar system. The solar system, a neighborhood of wonders. Our solar system is an extraordinary neighborhood, filled with planets, moons, asteroids, and comets that orbit our Sun, a star that provides the light and energy that sustains life on Earth. Mercury, the closest planet to the Sun, orbits at a blistering speed, completing a year in just 88 days. Despite its proximity to the Sun, Mercury's lack of atmosphere means its surface temperatures swing wildly, from over 400 degrees Celsius, 752 degrees Fahrenheit, during the day to minus 180 degrees Celsius, minus 292 degrees Fahrenheit, at night. Often called Earth's twin, Venus is shrouded in thick sulfuric acid clouds. Its surface is a scorching 475 degrees Celsius, 900 degrees Fahrenheit, hot enough to melt lead, and its atmosphere is dense enough to crush a spacecraft within moments. Mars, the red planet, is a world of canyons, volcanoes, and ancient riverbeds. It is our best hope for finding signs of past life, and perhaps even a future home for humanity. Farther out lie the gas giants Jupiter and Saturn, and the ice giants Uranus and Neptune. Jupiter, the largest planet in the solar system, could fit all the other planets inside it and still have room to spare. Its great red spot is a storm that has raged for centuries, more significant than the entire Earth. With its stunning rings made of ice and rock, Saturn is a jewel of the solar system. While Uranus and Neptune, the icy twins, boast supersonic winds and vibrant blue hues. Beyond Neptune lies the Kuiper belt, a region of icy bodies including Pluto and other dwarf planets. This frozen frontier stretches billions of kilometers from the Sun, marking the edge of the classical solar system. Even so, the solar system is just a tiny dot in the vast expanse of the Milky Way. The Milky Way, a galactic home. The Milky Way is a barred spiral galaxy with 200 billion to 400 billion stars and vast amounts of gas, dust, and dark matter. It is an incredible 1,000,000 light-years across, meaning it would take 1,000,000 years to travel from one side to the other, even at the speed of light. Our solar system resides in one of the Milky Way's spiral arms, about 27,000 light-years from the galactic center. This center is home to a supermassive black hole known as Sagittarius A, with a mass equivalent to 4 million suns. Despite its immense size, the Milky Way is just one galaxy among countless others. In our local cosmic neighborhood, it is joined by the Andromeda Galaxy, the Triangulum Galaxy, and dozens of smaller galaxies in a collection known as the Local Group, the Observable Universe, a sea of galaxies. As we venture beyond the Milky Way, the accurate scale of the universe begins to reveal itself. The Observable Universe, the part of the cosmos we can see and measure, contains an estimated 2 trillion galaxies. Each galaxy is a collection of billions or trillions of stars, planets, moons, and other celestial objects. Between galaxies lie immense voids, regions of almost space stretching millions of light-years. The cosmic web surrounds these voids, a vast network of filaments made of galaxies and dark matter that connects the universe like a spider's web. The distances involved are staggering. The nearest galaxy to the Milky Way, Andromeda, is 2.5 million light-years away. The most distant galaxies ever observed are over 13 billion light-years from Earth, meaning their light began its journey long before our planet even existed. What lies beyond? The observable universe spans 93 billion light-years, but it is only a fraction of the total cosmos. Beyond the edge of what we can see lies the unobservable universe, a realm that may be infinitely large and contain regions of space we will never reach or measure. Some theories suggest that our universe is just one bubble in a vast multiverse consisting of countless universes, each with its physical laws and constants. Others propose that the universe is finite but unbounded, curving back on itself like the surface of a sphere. Whatever lies beyond, the accurate scale of the cosmos is far greater than anything we can imagine. It reminds us of the humbling vastness of existence and the endless mysteries that await discovery. The universe is a place of unimaginable size and beauty, a vast stage where the drama of existence plays out on scales that defy comprehension. As we continue our journey through space, let us take a moment to reflect on the wonder of the cosmos and our small but significant place within it. Stars. The universe's beacons. Stars are the lighthouses of the universe, the celestial engines illuminating the darkness and fueling the cosmic cycle of creation. They are born from vast clouds of gas and dust, live vibrant lives powered by nuclear fusion, and die in spectacular displays that scatter the elements of life across the cosmos. From the faintest red dwarfs to the largest supergiants, stars are as diverse as they are awe-inspiring. The birth of stars. Cradles of creation. Stars are born in nebulae, vast interstellar gas and dust regions that act as stellar nurseries. These nebulae, like the famous pillars of creation in the Eagle Nebula, are some of the most breathtaking sights in the universe. The process begins when a region within the nebula becomes denser than its surroundings. Gravity pulls the gas and dust inward, causing the area to collapse and heat up. As the material compresses, it forms a spinning disk with a hot, dense core at its center. This core, known as a protostar, is the precursor to a star. Nuclear fusion ignites when the temperature and pressure in the protostar's core become high enough. Hydrogen atoms fuse to form helium, releasing an enormous amount of energy. This marks the birth of a star, a beacon of light and heat that will shine for millions or billions of years. The main sequence, a star's stable life. Most of a star's life is spent in a state of balance known as the main sequence. During this phase, the outward pressure from nuclear fusion in the core perfectly counteracts the inward pull of gravity. Small stars, the quiet burners. Stars with low mass, like red dwarfs, burn their hydrogen fuel slowly, shining faintly for tens to hundreds of billions of years. Red dwarfs are the most common type of star in the universe, yet none have ever died, as their lifespans exceed the current age of the cosmos. Medium stars, the story of the sun. Stars like our sun have a lifespan of about 10 billion years. They maintain a delicate equilibrium, steadily converting hydrogen into helium in their cores. As they age, these stars grow brighter and hotter, eventually exhausting their hydrogen and transitioning to the next stage of their lives. Massive stars. The cosmic giants. Stars, many times the mass of the sun, burn through their hydrogen fuel at an astonishing rate, living fast and dying young. These blue giants are incredibly bright, and their surfaces can reach temperatures over 400 degrees Celsius, 72 degrees 000 degrees Fahrenheit. Despite their short lifespans, just a few million years, they play a crucial role in the universe, forging heavy elements in their cores. The death of stars, a spectacular finale. Every star, no matter its size, must eventually die. The nature of its death is determined by its mass. Low-mass stars, white dwarfs. When stars like the sun exhaust the hydrogen in their cores, they expand into red giants, their outer layers swelling hundreds of times their original size. In this phase, the sun will engulf Mercury, Venus, and perhaps even Earth. After shedding their outer layers into space, forming a planetary nebula, the remaining core becomes a white dwarf, a small, dense object about the size of Earth. Massive stars, supernovae, and neutron stars. For massive stars, the end is far more dramatic. When they run out of fuel, their cores collapse under gravity, triggering a supernova explosion. These explosions release enormous amounts of energy, briefly outshining entire galaxies. The collapsed core can become a neutron star, an incredibly dense object composed almost entirely of neutrons. The most massive stars, black holes. Even a neutron star cannot support the collapsing core of the most prominent stars. These stars become black holes, regions of space where gravity is so intense that not even light can escape. Stars as the universe's alchemists. Stars are not just sources of light, they are the universe's alchemists, forging the elements that make up everything around us. The lightest elements, hydrogen and helium, were created in the first moments after the Big Bang. Heavier elements, such as carbon, oxygen, and iron, are formed in the cores of stars during nuclear fusion. When massive stars die in supernovae, they scatter these elements into space, seeding the cosmos with the building blocks of planets, life, and future stars. Carl Sagan once said, "We are made of star stuff." Every atom in your body was forged in the heart of a star, billions of years ago. The eternal cycle of stars. The death of one star begins another. The gas and dust expelled by dying stars create the raw materials for new stellar generations. This cycle of birth, life, and death has been repeating for billions of years, shaping the universe's evolution. Stars are the storytellers of the cosmos. Their light reveals the universe's history, and their deaths open new possibilities. As we continue our journey, let us focus on the next chapter in this cosmic story: black holes, the most mysterious objects in the universe. Black holes, the universe's most mysterious objects. Black holes are among the most fascinating and enigmatic phenomena in the universe. These cosmic enigmas push the boundaries of our understanding of physics, space, and time. They are regions of space where gravity is so immense that nothing, not even light, can escape. Invisible and silent, they lie hidden in the fabric of the cosmos, revealing their presence only through their effects on their surroundings. Black holes are not just objects of mystery. They are powerful engines of transformation, shaping galaxies, forging elements, and even bending the structure of space-time. What are black holes? Black holes form when massive stars reach the end of their lives. As the star exhausts its nuclear fuel, its core collapses under the immense force of gravity, compressing all of its mass into an incredibly small volume. This point, known as the singularity, is a region of infinite density, where the laws of physics cease to function. Surrounding the singularity is the event horizon, the boundary beyond which nothing can escape. Once an object crosses this threshold, it is lost forever to the black hole, unable to send any information back to the outside universe. There are three main types of black holes. Stellar mass black holes. These form from the remnants of massive stars and typically have masses ranging from a few to several dozen times that of the Sun. Supermassive black holes. Found at the centers of most galaxies, these giants have masses ranging from millions to billions of suns. The black hole at the heart of the Milky Way, Sagittarius A, has a mass of about 4 million suns. Intermediate mass black holes are a mysterious category, thought to form from merging stars or smaller black holes. They bridge the gap between stellar mass and supermassive black holes, the power of gravity. Spaghettification and event horizons. The immense gravitational pull of a black hole is its defining feature. As objects approach, they experience a phenomenon known as spaghettification. This occurs because the gravitational force is much stronger at the object's closest point to the black hole than at its farthest. The difference stretches the object, pulling it into a long, thin shape like a strand of spaghetti. The event horizon, often called the point of no return, marks the boundary where gravity becomes so strong that not even light can escape. Outside the event horizon, light and matter can still orbit the black hole in complex paths, creating spectacular displays of energy and motion. Accretion disks, the light around the darkness. While black holes emit no light, the material falling into them creates some of the brightest phenomena in the universe. As gas and dust spiral toward the event horizon, they form an accretion disk, a swirling ring of material heated to millions of degrees by friction and gravitational forces. This intense heat causes the disk to emit radiation across the electromagnetic spectrum, from visible light to X-rays and gamma rays. Observations of accretion disks allow scientists to study black holes indirectly, measuring their mass, spin, and effects on nearby objects. In some cases, black holes eject relativistic jets, streams of charged particles traveling near the speed of light. These jets are powered by the black hole's spin and the magnetic fields of the accretion disk. They extend vast distances, often spanning entire galaxies, and can create brilliant radio-loud phenomena like quasars, time and space around black holes. One of the most mind-bending aspects of black holes is their effect on time and space. According to Einstein's theory of general relativity, massive objects like black holes warp the fabric of space-time, creating profound distortions. Time dilation near a black hole, time slows dramatically. For an observer far away, a clock near the event horizon would tick more and more slowly. At the event horizon itself, time seems to stop altogether. This phenomenon, known as gravitational time dilation, means that objects near a black hole experience time differently from the rest of the universe. Gravitational lensing, black holes, can bend light around them, creating gravitational lensing effects. This can make objects behind a black hole appear distorted or duplicated, creating eerie and beautiful visuals in the night sky. How do we study black holes? Despite their invisibility, black holes can be studied through their interactions with surrounding matter and their effects on light and space-time. Scientists use several methods to observe and analyze these enigmatic objects. X-ray observations. Telescopes like the Chandra X-ray Observatory detect the intense X-rays emitted by accretion disks. Radio telescopes, instruments like the Event Horizon Telescope, have captured images of black holes by observing radio waves from their surroundings, such as the historical image of the black hole in the galaxy M87. Gravitational waves. The collision of black holes produces ripples in space-time, known as gravitational waves. LIGO first detected these waves in 2015, marking a groundbreaking moment in astrophysics. The role of black holes in the universe. Black holes are not just destructive forces, but also essential to the structure and evolution of the universe. Galactic architects. Supermassive black holes at the centers of galaxies play a crucial role in shaping their formation and dynamics. Their immense gravity influences the motion of stars and gas, while their jets can regulate star formation by heating and dispersing gas clouds. Cosmic recycling. The material expelled during supernovae and black hole interactions helps seed the cosmos with heavy elements, fueling the formation of new stars and planets. Pushing the limits of physics. Black holes are laboratories for extreme physics, where scientists can study phenomena like quantum gravity, space-time singularities, and the behavior of matter under extreme conditions. The mysteries that remain. For all we have learned about black holes, they remain deeply mysterious. What lies beyond the event horizon? Is the singularity truly a point of infinite density, or does it represent a new phase of matter or space-time? Some theories suggest that black holes could be gateways to other universes, or that their interiors might contain information about the origins of the cosmos. As our technology and understanding advance, black holes will continue to challenge and expand the limits of human knowledge. Black holes are the ultimate paradoxes of the universe, both invisible and brilliant, destructive and creative, unknowable and essential. As we continue exploring their mysteries, they remind us of the infinite possibilities within the cosmos. Let us now turn to another chapter in this journey. The solar system, our backyard. The solar system, our cosmic backyard. Our solar system is a microcosm of the universe, a place of extraordinary diversity where planets, moons, asteroids, and comets tell their own story of formation and evolution. While the universe is almost incomprehensibly vast, the solar system is close enough for us to explore and study in detail. It is our cosmic home, and within its boundaries lie countless wonders that continue to amaze and intrigue us. The Sun, the heart of the solar system. At the center of the solar system lies the Sun, a glowing sphere of hydrogen and helium that accounts for 99.8% of the solar system's total mass. The Sun is a G-type main sequence star, or yellow dwarf, and its energy sustains life on Earth while shaping the planet's orbits and climates. The Sun generates energy through nuclear fusion, fusing hydrogen atoms into helium in its core. This process releases immense energy, radiated outward as heat and light. The Sun's surface temperature is approximately 5,500 degrees Celsius, 9,932 degrees Fahrenheit, while its core reaches a staggering 15 million degrees Celsius. But the Sun is not just a source of light, it is a dynamic, ever-changing entity. Solar flares, coronal mass ejections, and sunspots are constant reminders of the Sun's immense power. These phenomena can even impact Earth, causing geomagnetic storms that produce dazzling auroras while disrupting satellites and communication systems. The Sun is about 4.6 billion years old, and it is roughly halfway through its life. In about 5 billion years, it will expand into a red giant, engulfing the inner planets before shedding its outer layers to become a white dwarf. The inner planets, rocky worlds close to the Sun. The inner planets, Mercury, Venus, Earth, and Mars, are small, rocky worlds with solid surfaces. Each one is unique, shaped by its distance from the Sun and its geological history. Mercury, the closest planet to the Sun, Mercury is a world of extremes. Its surface is heavily cratered, resembling the Moon, and temperatures range from 430 degrees Celsius, 800 degrees Fahrenheit, during the day to minus 180 degrees Celsius, minus 290 degrees Fahrenheit at night. With almost no atmosphere, Mercury is a silent, desolate place. Venus, often called Earth's twin due to its similar size and composition, Venus is anything but hospitable. Its thick atmosphere of carbon dioxide traps heat in a runaway greenhouse effect, creating surface temperatures of 475 degrees Celsius, 900 degrees Fahrenheit, hotter than Mercury. The atmosphere's sulfuric acid clouds and crushing pressure make it one of the most hostile places in the solar system. Earth, our home, is a rare and precious world teeming with life and liquid water. Its magnetic field and atmosphere protect it from solar radiation, while its distance from the Sun creates the perfect conditions for life to thrive. Mars. The red planet is a frozen desert with a thin carbon dioxide atmosphere. Evidence of ancient riverbeds and lake beds suggests Mars once had liquid water on its surface. Today, it remains one of the most intriguing targets for exploration, with rovers like Perseverance searching for signs of past life. The outer planets, giants of the solar system. The outer planets, Jupiter, Saturn, Uranus, and Neptune, are gas giants and ice giants, immense worlds composed primarily of hydrogen, helium, and other gases. Jupiter is the largest planet in the solar system. Jupiter could fit all the other planets inside it and still have room to spare. Its great red spot is a storm that has raged for over 300 years, while its magnetic field is the strongest of any planet. Jupiter also has at least 95 moons, including Europa, which may harbor a subsurface ocean beneath its icy crust. Saturn? A gas giant with a unique beauty, Saturn is famous for its spectacular rings. These rings are composed of billions of ice particles ranging in size from tiny grains to boulders. Saturn's largest moon, Titan, has lakes of liquid methane and a thick atmosphere, making it one of the most Earth-like worlds in the solar system. Uranus. This ice giant is unique for its sideways rotation, with its axis tilted at an angle of 98 degrees. Its pale blue color comes from methane in its atmosphere. The planet experiences some of the coldest temperatures in the solar system, dropping to minus 224 degrees Celsius, minus 371 degrees Fahrenheit. Neptune. The farthest planet from the Sun, Neptune is a world of supersonic winds and vibrant blue hues. Its largest moon, Triton, orbits opposite Neptune's rotation, suggesting it was captured from the Kuiper belt. The Kuiper belt and beyond. The icy frontier. Beyond Neptune lies the Kuiper belt, a region of icy bodies and dwarf planets. Pluto, once considered the 9th planet, is among them. Its surface is a frozen expanse of nitrogen and methane, with towering ice mountains and a thin atmosphere that collapses and reforms as it orbits the Sun. Even farther out lies the Oort cloud, a theoretical shell of icy objects that surrounds the solar system. It is thought to be the source of long-period comets, which occasionally venture into the inner solar system, creating spectacular displays in the night sky. Moons, the other worlds of the solar system. The solar system is home to over 200 moons, many of which are as fascinating as the planets themselves. Europa. Beneath its icy surface lies a vast ocean of liquid water, kept warm by tidal forces. Europa is one of the most promising places to search for extraterrestrial life. Enceladus, Saturn. This tiny moon ejects plumes of water vapor and organic molecules into space from its subsurface ocean. Titan, Saturn. Titan's thick atmosphere and liquid methane lakes make it a world of unique chemistry, with conditions that might support exotic forms of life, a dynamic and ever-changing system. The solar system is not static, it is a dynamic, evolving system. Planets migrate, moons shift, and comets and asteroids constantly interact with the inner planets. Over billions of years, the solar system has changed dramatically, and it will continue to do so as the sun ages and its planets adapt to new conditions. The solar system is our cosmic backyard, a place of incredible diversity and beauty. As we explore it further, we deepen our understanding not only of the cosmos, but of our origins. Let us now venture beyond our solar system to worlds and phenomena that lie in the vast reaches of interstellar space. Exoplanets, other worlds in the cosmos. Beyond the edges of our solar system lies a universe filled with trillions of stars, each a potential home to planets we can only imagine. These distant worlds, known as exoplanets, have revolutionized our understanding of the cosmos. Just a few decades ago, planets outside our solar system were purely speculative. Today, thanks to advanced telescopes and groundbreaking discoveries, we know that exoplanets are not only familiar, they may number in the trillions across the universe. With each discovery, we are reminded that our solar system is just one example among countless others, and the possibilities for other worlds are as limitless as the stars themselves. The discovery of exoplanets. The search for exoplanets began in earnest in the 1990s, and since then, scientists have identified more than 5,500 confirmed exoplanets as of 2025. With thousands more awaiting confirmation. These discoveries have been made possible by ingenious detection methods, each revealing a different aspect of these distant worlds. The transit method, the most successful method, the transit method, detects exoplanets as they pass in front of their stars, causing a tiny but measurable dip in their brightness. NASA's Kepler Space Telescope used this method to discover thousands of exoplanets, revealing a universe teeming with planetary systems. The radio velocity method. Scientists can infer the presence of exoplanets by measuring the slight wobble of a star caused by the gravitational pull of an orbiting planet. This method has been particularly effective for detecting massive planets close to their stars, known as hot Jupiters. Direct imaging and gravitational microlensing. Although challenging, direct imaging captures actual pictures of exoplanets by blocking out the light of their host stars. On the other hand, gravitational microlensing uses the bending of light caused by a massive object to reveal hidden planets. The incredible diversity of exoplanets. Exoplanets are of an astonishing variety. Some are familiar, while others are utterly alien, challenging our ideas of what a planet can be. Hot Jupiters. These gas giants orbit their stars at incredibly close distances, with surface temperatures exceeding 2,000 degrees Celsius, 3,600 degrees Fahrenheit. Their atmospheres are often stripped away by their stars, creating tails of gas that make them resemble comets. Super-Earths. These rocky planets are more significant than Earth, but smaller than Neptune. Some may have thick atmospheres, oceans of liquid water, or surfaces covered in molten lava. Examples like Kepler 452b sit in the habitable zone of their stars, where conditions could support life. Mini-Neptunes, smaller versions of our solar system's ice giants, these planets may have thick atmospheres of hydrogen and helium, with icy or rocky cores beneath, rogue planets. Some planets wander through space without orbiting a star. These rogue planets, ejected from their original systems, drift in the darkness, lit only by faint starlight or their internal heat. Exotic worlds. Some exoplanets defy categorization, like Kepler-10b, a world so close to its star that its surface is likely an ocean of molten rock. Others, like 55 Cancri e, are thought to have diamond-rich interiors due to their carbon-based composition. The search for life, the habitable zone. One of the most compelling aspects of exoplanet research is the search for life. Scientists focus on planets in the habitable zone, the region around a star where conditions might allow liquid water to exist. Planets like Kepler-22b and Proxima Centauri b orbit in their stars' habitable zones, raising the possibility of alien life. However, being in the habitable zone does not guarantee habitability. Factors like atmospheric composition, magnetic fields, and geological activity all play critical roles in making a planet suitable for life. The search for life extends beyond Earth-like planets. Moons of gas giants, like Europa and Titan in our own solar system, may provide clues about how life could thrive in unexpected places. The future of exoplanet exploration. The next generation of telescopes is poised to revolutionize our understanding of exoplanets. The James Webb Space Telescope has already begun detecting atmospheres around exoplanets, analyzing their chemical composition for signs of water, oxygen, methane, and other potential biosignatures. Future missions like LUVOIR, Large Ultraviolet Optical Infrared Surveyor, aim to image Earth-like planets and search for signs of life directly. Ground-based observatories, such as the Extremely Large Telescope, ELT, will complement these efforts by studying exoplanets in unprecedented detail. As technology advances, we may one day discover the first definitive evidence of life beyond Earth, an event that would forever change our understanding of the universe and our place within it. The profound implications of exoplanets. The discovery of exoplanets has transformed our view of the cosmos. It has shown us that our solar system is not unique, but one of countless systems scattered across the galaxy. Each exoplanet is a reminder of the diversity and creativity of nature, a testament to the endless possibilities of the universe. Perhaps among these distant worlds, there are planets where life has taken root, where civilizations have risen and fallen, and where beings gaze at their own stars, wondering if they are alone. The search for exoplanets is more than a scientific endeavor. It is a journey of imagination, a quest to understand the universe and our place within it. As we continue our exploration, let us turn our attention to the invisible forces that shape the universe, dark matter and dark energy, and the mysteries they hold, the mysteries of dark matter and dark energy. The universe, for all its beauty and complexity, hides most of its true nature. Everything we can see, stars, galaxies, planets, and even ourselves, makes up less than 5% of the universe's total content. The remaining 95% is composed of two mysterious and invisible components, dark matter and dark energy. Though we cannot see or touch them, their presence shapes the cosmos in profound ways. Dark matter binds galaxies together, while dark energy drives the accelerated expansion of the universe. Together, they are the unseen architects of the cosmos, controlling its structure, evolution, and ultimate fate. Dark matter, the universe's hidden scaffolding. Dark matter is a form of matter that does not emit, absorb, or reflect light. It is entirely invisible to telescopes, yet its effects can be observed through its gravitational influence. How do we know dark matter exists? The idea of dark matter arose when scientists noticed that galaxies were rotating in ways that defied expectations. Based on visible matter alone, the outer edges of galaxies should rotate more slowly than their inner regions. However, observations show that galaxies spin as if they are embedded in massive halos of The gravitational effects of dark matter can also be seen in gravitational lensing, where light from distant galaxies is bent and distorted by massive, invisible structures. What is dark matter? Despite decades of study, the exact nature of dark matter remains unknown. It is not made of ordinary atoms like the matter we interact with every day. Instead, it may consist of exotic particles that interact weakly with other matter. Leading candidates for dark matter include WIMPs, weakly interacting massive particles, and axions, theoretical particles that could explain dark matter's strange behavior. The cosmic web dark matter is thought to form the backbone of the universe, creating a vast cosmic web of filaments and nodes. Galaxies and galaxy clusters are embedded within this web, forming along its dense intersections. Without dark matter, the universe as we know it could not exist. Its gravitational pull was essential in shaping the large-scale structure of the cosmos, guiding the formation of galaxies and clusters over billions of years. Dark energy, the force behind the universe's expansion. If dark matter is the universe's scaffolding, then dark energy is its driving force. Discovered in the late 1990s, dark energy is the mysterious phenomenon responsible for the accelerated expansion of the universe. The discovery of dark energy, for most of the 20th century, scientists believed that the universe's expansion, caused by the Big Bang, was slowing down due to gravity. However, observations of distant supernovae revealed something unexpected. The universe is not slowing down. It is speeding up. This acceleration could only be explained by the presence of a previously unknown force, which we now call dark energy. What is dark energy? Like dark matter, dark energy's nature is a profound mystery. It is often described as a property of space itself, a kind of energy that arises simply from the existence of empty space. One explanation for dark energy is the cosmological constant, a concept introduced by Albert Einstein. In this view, dark energy has a constant density throughout the universe, driving its steady acceleration. Another possibility is that dark energy is dynamic, changing over time. If this is the case, it could lead to vastly different outcomes for the universe's future. The role of dark energy in the universe's fate. Dark energy determines the ultimate fate of the universe. If it continues to dominate, the universe will expand forever, leading to a cold, dark, and empty future known as the Big Freeze. If dark energy grows stronger, it could tear the cosmos apart in a catastrophic event called the Big Rip. Alternatively, if dark energy weakens or reverses, the universe could stop expanding and collapse in a fiery Big Crunch, potentially leading to a new Big Bang. The intersection of dark matter and dark energy. Dark matter and dark energy are not opposing forces. They coexist, shaping the universe on different scales. Dark matter holds galaxies together, creating the structure we observe, while dark energy works on the largest scales, driving the expansion of space itself. The balance between these forces is delicate and complex. Without dark matter, galaxies would fly apart. Without dark energy, the universe's expansion might slow and collapse. Together, they create a dynamic and evolving cosmos where structure and motion are inextricably linked. The unsolved mysteries of the universe. Despite all we have learned about dark matter and dark energy, their true nature remains elusive. They challenge the limits of our understanding, hinting at physics beyond the standard model and new dimensions of reality. Dark matter's identity. What are the particles that make up dark matter? Could they reveal a hidden side of the universe governed by forces we have yet to discover? Dark energy's origins. Is dark energy a constant force, or does it change over time? Could it be linked to quantum fields or extra dimensions? Unifying the forces, dark matter and dark energy, may hold the key to a unified theory of physics, connecting the very small, quantum mechanics, with the very large, general relativity. A universe of shadows and light. The universe is not what it seems. Beneath the visible lies an invisible world of shadows, where dark matter and energy shape everything we see and everything we are. They are the silent forces that guide the evolution of galaxies, stars, and planets, holding the cosmos together. while driving it apart. As we continue to study these mysteries, we are reminded of how much we have yet to learn. The search for answers is not just a scientific pursuit. It is a journey into the unknown, a quest to understand the very fabric of existence. Let us now venture deeper into the universe, exploring the astonishing phenomena of galaxies and intergalactic wonders. Galactic wonders and intergalactic phenomena. Galaxies are the grand masterpieces of the universe, vast collections of stars, gas, dust, and dark matter that come together to form the most spectacular structures in existence. These luminous beacons are far more than isolated islands of light. They are the engines of cosmic evolution, the nurseries of stars and planets, and the cornerstones of the universe's large-scale structure. Beyond their beauty, galaxies interact with one another and with the invisible forces that govern the cosmos, creating astonishing phenomena that stretch our imagination. From dazzling collisions and luminous quasars to the intricate cosmic web that connects galaxies across vast distances, the story of galaxies is the story of the universe itself, a tale of creation, destruction, and unending transformation. The diversity of galaxies, shapes, and structures across the cosmos. Galaxies are as diverse as the stars they contain, each one shaped by its history, environment, and the interplay of gravity and matter. Astronomers classify galaxies into several main types, but even within these categories, the variety is astonishing. Spiral galaxies, the universe's grand design, spiral galaxies, like our own Milky Way, are among the most striking cosmic structures. Their flat, disc-like shapes are adorned with sweeping arms of stars and gas that spiral outward from a dense central bulge. These arms are the sites of active star formation, glowing brightly with the light of young, hot stars. Dark lanes of interstellar dust wind through the arms, creating a stark contrast against the luminous backdrop. Spiral galaxies can range from small, delicate structures to immense systems like Andromeda, which contains over 1 trillion stars and spans more than 2,000 light years. Light years are the vectors between stars' lives and, like Andromeda's in-people, elliptical galaxies. Massive and ancient, elliptical galaxies are the largest and most massive galaxies in the universe, often containing trillions of stars. Unlike spirals, they lack a defined structure and are instead spherical or oval in shape. These galaxies are composed primarily of older red stars, with little gas or dust remaining to fuel new star formation. They are the remnants of galactic mergers, their chaotic pasts hidden beneath calm, featureless exteriors. The largest elliptical galaxy, IC 1101, stretches over 5.5 million light-years, dwarfing even the Milky Way. Irregular galaxies, cosmic wildcards. Irregular galaxies defy classification, with chaotic shapes that often result from gravitational interactions or collisions with other galaxies. These galaxies are rich in gas and dust, making them fertile grounds for intense bursts of star formation. Dwarf galaxies. Small but significant, dwarf galaxies are the most common type of galaxy in the universe, though their faint light makes them challenging to detect. They contain just a few billion stars compared to the hundreds of billions found in larger galaxies. Despite their small size, dwarf galaxies play a critical role in the evolution of larger galaxies, often merging with them and contributing their stars and gas. Galactic collisions, a dance of giants. Galactic collisions are among the most spectacular events in the universe, reshaping galaxies on a grand scale. Though the distances between stars are so vast that individual stars rarely collide, the gravitational interactions between galaxies create rippling effects that reshape their structures and trigger dramatic phenomena. The collision of the Milky Way and Andromeda. The Milky Way is on a collision course with the Andromeda Galaxy, our closest large neighbor. Traveling toward each other at 110 kilometers per second, the two galaxies will meet in about 4.5 billion years. As they collide, their stars will be thrown into new orbits, and vast clouds of gas and dust will compress, sparking bursts of star formation. Over millions of years, the two galaxies will merge into a single, massive, elliptical galaxy. Often called Milkometa starburst galaxies, during collisions, the compression of gas clouds can lead to intense periods of star formation, creating galaxies known as starburst galaxies. These galaxies shine brightly in infrared and visible light, powered by the heat and radiation of newly formed stars. Galactic cannibalism. Larger galaxies often consume smaller ones in a process known as galactic cannibalism. The smaller galaxy is gradually torn apart by tidal forces. Its stars and gas are absorbed into the larger galaxy. The Milky Way is consuming several dwarf galaxies, including the Sagittarius dwarf elliptical galaxy, Quasars, the universe's brilliant beacons. Quasars are among the most energetic and luminous phenomena in the universe. Powered by supermassive black holes at the centers of galaxies, these cosmic beacons can outshine entire galaxies, emitting light across vast distances. The mechanism behind quasars. Quasars form when gas and dust spiral into the accretion disk of a supermassive black hole. The intense heat generated by friction causes the disk to emit massive amounts of energy, from visible light to X-rays and gamma rays. Jets of charged particles, driven by the black hole's magnetic fields, are ejected at nearly the speed of light, creating some of the brightest and most spectacular phenomena in the cosmos. Quasars as probes of the early universe. Jung-Jamesons believes, because light from quasars travels billions of years to reach us, they provide a window into the distant past, revealing conditions in the early universe. The recent wars of projectors dominate the Middle East have been odd and exciting, while scientists have recently discovered that 3.6 billions of years, the most distant quasar ever discovered, J03131806, dates back to just 670 million years after the Big Bang, offering valuable insights into the formation of the first galaxies and black holes. The cosmic web, the universe's skeleton. Galaxies are not scattered randomly across the universe. Instead, they are arranged in a cosmic web, a vast structure shaped by dark matter and gravity. Filaments and nodes. The filaments of the cosmic web are made of galaxies, gas, and dark matter, stretching across the universe in intricate patterns. At the intersections of these filaments lie galaxy clusters, massive structures containing thousands of galaxies, bound together by gravity, voids. The cosmic wastelands between the filaments are immense voids, regions of space almost entirely devoid of galaxies. These voids can span hundreds of millions of light years, creating stark contrasts with the dense filaments. The role of dark matter. Dark matter acts as the scaffolding of the cosmic web. Galaxies, the engines of creation. Galaxies are far more than collections of stars. They are the engines of cosmic creation, the cradles of planets and life, and the building blocks of the universe. Each galaxy is a testament to the beauty, complexity, and dynamism of the cosmos. As we study their formation, interactions, and evolution, we uncover the grand story of the universe itself, a tale of endless creativity and transformation. Let us now explore the concept of cosmic time and the ultimate future of the universe, a journey into the unknown depths of eternity. Cosmic time and the universe's future. The concept of time takes on a profound new meaning when applied to the cosmos. On Earth, we measure time in hours, days, and years, units tied to the motion of our planet around the sun. But in the vastness of the universe, these measures are fleeting, almost insignificant. Cosmic time is measured in billions of years, encompassing the lifetimes of stars, the evolution of galaxies, and the ultimate fate of the universe itself. The story of cosmic time is both humbling and awe-inspiring. It is a tale of beginnings and endings, of cycles and transformations written across the infinite canvas of space. To understand it is to glimpse the grand narrative of the cosmos, a timeline that extends far beyond the limits of human existence. The beginning of time, the Big Bang, and the early universe. The story of cosmic time begins approximately 13.8 billion years ago with the Big Bang, the event that marked the birth of the universe. At that moment, all matter, energy, space, and even time itself were compressed into a singular point of infinite density. What caused the Big Bang remains one of the greatest mysteries in cosmology, but its aftermath is written in the very fabric of the universe. The first moments, inflation and cooling. In the first fraction of a second, the universe underwent a period of rapid expansion known as cosmic inflation. During this time, the universe grew exponentially, from smaller than an atom to the size of a galaxy in an instant. As the universe expanded, it also cooled. Within the first few seconds, the fundamental forces of nature, gravity, electromagnetism, and the strong and weak nuclear forces emerged, shaping the behavior of the cosmos. The formation of matter, the intense heat of the early universe, caused particles to form and collide at extraordinary speeds. Quarks combined to form protons and neutrons, the building blocks of atoms. Within the first few minutes, light elements like hydrogen, helium, and trace amounts of lithium were forged in a process known as primordial nucleosynthesis. These elements would later form the stars and galaxies we see today, and the elements would later form the stars and galaxies we see today, the era of light. The cosmic microwave background. For the first 3,8,0,0,0 years, the universe was a hot, dense plasma where light could not travel freely. As the universe cooled, electrons combined with protons to form neutral atoms, allowing light to escape for the first time. This light, known as the cosmic microwave background radiation, is the oldest observable relic of the universe. And the cosmic microwave background radiation is the oldest observable relic of radiation. Is the oldest observable relic of the universe. It provides a snapshot of the cosmos in its infancy and is a key tool for understanding its origins. The cosmic dawn, the first stars and galaxies. For hundreds of millions of years after the Big Bang, the universe was a cold, dark expanse filled with diffuse hydrogen and helium. But gravity was at work, pulling matter together into dense regions. These regions grew hotter and denser until nuclear fusion ignited, giving birth to the first stars. The first stars, these early stars, known as population 3 stars, were massive and short-lived, burning through their fuel quickly before exploding as supernovae. So the supernovae enriched the surrounding gas with heavier elements, paving the way for the next generation of stars and planets, the birth of galaxies. The first galaxies formed as stars clustered together, drawn by gravity. These primitive galaxies were small and irregular, but over billions of years they evolved into the magnificent spirals, ellipticals, and other shapes we see today. Galaxies became the building blocks of the universe's large-scale structure, assembling into clusters, superclusters, and the vast cosmic web, the present era, a universe in motion. Today, the universe is a place of incredible activity and beauty. Stars are born in nebulae, live out their lifespans in radiant brilliance, and die in spectacular explosions. Galaxies continue to evolve, interacting with one another and shaping the cosmic landscape. The expanding universe. One of the most significant discoveries in modern cosmology is that the universe is not static, but expanding. This expansion, driven by dark energy, is accelerating, causing galaxies to move farther apart over time. The Hubble constant measures the rate of this expansion, providing insights into the universe's age and evolution. Star formation and galactic evolution. Star formation occurs in regions rich with gas and dust, such as the Orion Nebula. These stellar nurseries are the birthplaces of new stars, planets, and solar systems. Galaxies evolve through collisions, mergers, and the influence of supermassive black holes at their centers, creating a dynamic and ever-changing universe. The far future. The fate of the universe. As we look to the distant future, the ultimate fate of the universe comes into focus. While many uncertainties remain, scientists have proposed several scenarios based on our understanding of dark energy, dark matter, and the fundamental forces of nature. The Big Freeze, a slowly fading cosmos. If the universe continues to expand indefinitely, it will grow colder and darker over time. Star formation will cease as gas and dust are depleted, leaving behind only white dwarfs, neutron stars, and black holes. Over trillions of years, even black holes will evaporate through Hawking radiation, leaving a universe of scattered particles and faint heat. The Big Rip, a catastrophe end. If dark energy becomes stronger over time, it could tear the universe apart in a scenario known as the Big Rip. Galaxies, stars, planets, and even atoms would be ripped apart, leaving only a chaotic sea of particles. The Big Crunch, a fiery collapse. If dark energy weakens, the universe expansion could reverse, causing galaxies to collapse back together. This Big Crunch could lead to a new Big Bang, starting the cycle anew. Time beyond time, a legacy of light and darkness. Even in the farthest reaches of time, the universe leaves behind a legacy. The elements forged in stars, the structures shaped by gravity, and the light emitted by countless galaxies will echo across eternity. The story of cosmic time is one of transformation and resilience, a testament to the creativity of the cosmos. Reflections on cosmic time. The universe is a vast and ever-changing entity, its timeline stretching far beyond our comprehension. Contemplating cosmic time is to confront the infinite, marvel at the scale of existence, and find meaning in our fleeting moments within the grand story of the cosmos. As we conclude our journey, let us reflect on the beauty and mystery of the universe and our small but significant place within it. The conclusion. Reflecting on the mysteries of the cosmos, the universe is vast beyond measure, a seemingly infinite expanse filled with wonders that challenge our understanding and inspire our imaginations. It is a place of astonishing beauty and profound mystery, where every star, planet, and galaxy holds a story billions of years in the making. As we journey through the cosmos, we are reminded of how much we have discovered and how much remains unknown. From the birth of stars and glowing nebulae to the silent, invisible forces of dark matter and energy, the cosmos offers a tapestry of phenomena that defy explanation. It is both a mirror that reflects our curiosity and a frontier that pushes us to expand our understanding of existence. Yet, for all the questions we have answered, the universe keeps its deepest secrets. A reminder that mystery is as fundamental to the cosmos as the stars themselves, a journey through space and time. Over the past few hours, we have explored the vast expanse of space, uncovering the remarkable facts and mysteries that define our universe. We have journeyed from the birth of time during the Big Bang to the distant future of the cosmos, contemplating its ultimate fate. Along the way, we have visited the stars, peered into black holes, and marveled at the structures that span billions of light years. We have learned about the astonishing diversity of exoplanets, the forces that govern galaxies, and the dynamic processes that give rise to stars and planets. We have seen how dark matter and dark energy, though invisible, shape the very structure and destiny of the universe. And we have reflected on the role of cosmic time, a vast timeline so vast that our brief human existence is a single flicker in its grand narrative. The universe is a source of wonder. The cosmos is more than a collection of stars, galaxies, and planets. It is a source of endless wonder. Humans have gazed at the night sky for millennia, captivated by its beauty and driven to understand its mysteries. Ancient civilizations created myths and stories to explain the stars, while modern science has unlocked many secrets. Yet, even as our understanding grows, the universe surprises us, revealing new questions with every answer. This sense of wonder is one of humanity's greatest gifts. It connects us to something greater than ourselves, reminding us that we are part of a vast and interconnected cosmos. This wonder inspires scientists to build telescopes that peer into the farthest reaches of space, poets to write about the beauty of the night sky, and each of us to pause and marvel at the stars above. The fragility of our place in the cosmos. Amidst the universe's immensity, Earth is a fragile sanctuary, a tiny world orbiting an ordinary star on the outskirts of the Milky Way, yet it is the only place we know of where life exists. Every breath we take, every step we take, reminds us of the delicate balance that sustains us. Carl Sagan once described Earth as a mote of dust, suspended in a sunbeam. His words remind us of the importance of caring for our planet, not only because it is our home, but also because it is a rare and precious part of the universe. Contemplating the cosmos reminds us not only of its vastness, but also of our responsibility to protect the small corner of it we call home. The unending quest for knowledge, the mysteries of the universe beckon us to explore, imagine, and seek answers. Each question we ask brings us closer to understanding the cosmos, yet it also reveals new layers of complexity. This unending quest for knowledge is the essence of science, a journey that is as much about discovery as the wonder of not knowing. As we build more advanced telescopes, send probes to distant worlds, and develop new theories of physics, we are not only expanding our knowledge, but also enriching our sense of what it means to be human. The search for answers is not a solitary endeavor. It is a collective effort that unites us across cultures, generations, and disciplines, a universe of infinite possibilities. The universe is a place of infinite possibilities, a realm where stars are born and die, galaxies collide and evolve, and life itself emerges from the elements forged in ancient stars. It reminds us that the cosmos is not static but dynamic, a place of constant change and boundless creativity. Even as we uncover the secrets of the universe, we are left with profound questions that challenge the limits of our understanding. What lies beyond the observable universe? What is the nature of dark matter and dark energy? And are we alone in this vast cosmic expanse? These questions may never be fully answered, but that is part of the beauty of the cosmos. Its mysteries are not problems to be solved. They are invitations to wonder, to imagine, and to dream. A call to curiosity. As we conclude our journey, let us carry the awe and curiosity inspired by the universe. The cosmos is vast, but it is also deeply personal, a mirror that reflects our desire to understand, connect, and find meaning. Whether you are a scientist gazing through a telescope, a poet writing about the stars, or a dreamer watching the night sky, the universe belongs to all of us. It is a shared inheritance, a reminder that we are not alone in our curiosity, wonder, or search for answers.